September 2025. The sky turns into a cosmic crossroads as 7 comets rush toward Earth and the Sun at the same time. Leading the charge is 3I Atlas, the interstellar giant with a strange structure and an unusual path, visiting only once and never coming back. Meanwhile, SWAN and Lemmon suddenly flare 10 times brighter than expected, far beyond all predictions. This is a once-in-a-lifetime chance to see with our own eyes, something humanity today will never witness again. Will this rare swarm of comets trigger powerful solar storms or reveal the secrets of how planets are born? For centuries, comets have come and gone, but almost all of them belong to our own solar system. They were icy leftovers from its birth, moving in long loops that always tied them back to the sun. That is why the discovery of objects from outside this system was such a shock to science. In 2017, the first true interstellar visitor arrived and was called Oumuamua, which means scout in Hawaiian. It was small, flat, and mysterious, and the way it accelerated after passing the sun made scientists wonder if it was natural at all. Some believed it was made of exotic ice that evaporated in strange ways, while others whispered that it might even be alien technology. Just 2 years later, another foreigner appeared, named 2I Borisov, and this time it looked like a classic comet with a bright tail. But its chemistry was unusual, holding much more carbon monoxide than local comets, showing it had formed in a colder and more distant environment. Both Oumuamua and Borisov were brief, flashing across the sky and leaving more questions than answers. By the start of 2025, only 2 such visitors had ever been confirmed, and astronomers thought it might be decades before another appeared. Then came the surprise. In July, telescopes spotted a new giant rushing in, brighter and bigger than the 2 before it, and it was quickly named 3I Atlas. This object was clearly not born in our solar system, and its hyperbolic orbit meant it would never come back once it left. But 2025 did not stop with one headline discovery. 6 other comets also began diving toward the inner solar system in the same short season, creating a crowd never recorded in modern times. Normally, only 1 or 2 comets reach brightness levels worth studying each year, and even that is considered lucky. This time, 7 major comets lined up within months, making the sky feel like a busy crossroads filled with icy wanderers. For the first time, scientists could compare an interstellar comet directly with local ones, side by side, under the same solar conditions. It became a natural laboratory to test long-standing theories. Would the chemistry of 3I Atlas match the ingredients of our comets, or would it reveal a recipe from another star system? And with so many diving into the sun's magnetic field at once, could their combined impact trigger powerful space storms? The stage was set, but the real story begins with the strange body at the center of it all. So what exactly makes 3I Atlas stand out as the fossil of another world? 3I Atlas is not just another comet, it is the 3rd confirmed interstellar object ever found, and it has already shocked scientists with its size and speed. Discovered on July 1, 2025, astronomers needed less than 24 hours to confirm that its orbit was hyperbolic, which means it is not bound to the sun. Instead of circling back like the comets we know, it will pass through the solar system once and then vanish into deep space forever. This fact alone makes it unique, but the details make it even more extraordinary. Measurements show that its nucleus could be as large as 24 kilometers across, much bigger than most comets seen in modern history. It races through space at more than 200,000 kilometers per hour, a speed that underlines its alien origin. Astronomers believe that 3I Atlas formed billions of years before our solar system, which makes it like a frozen fossil from another star's backyard. Images from powerful telescopes such as Gemini North, Hubble, and Palomar reveal a coma so large it dwarfs Earth, stretching to nearly 700,000 kilometers across. The composition is also unusual, filled with carbon dioxide, nickel, and traces of cyanide, but surprisingly poor in water vapor. This is not what scientists expect from comets inside our solar system, which usually release huge amounts of water when they approach the Sun. The absence of water makes 3I Atlas different, a chemical fingerprint that proves it was born in conditions we have never studied before. Because of its hyperbolic path, astronomers know it is not a visitor we can wait to see again. It will sweep around the Sun once, then disappear into the galactic night without returning. That reality has created an urgent race among observatories worldwide to collect as much data as possible before it is gone. Every night, teams point their instruments at this alien body, hoping to capture information about its dust, gas, and magnetic interactions. For researchers, 3I Atlas is not just a comet, it is a once-in-a-lifetime messenger that carries the history of a different star system. It gives us a rare chance to compare local comets with an outsider and maybe discover if the building blocks of other planets look like our own. If the story of 3I Atlas is already rewriting science, what surprises might the other bright comets of 2025 still hold? If 3I Atlas was the giant that set the stage, then SWAN and Lemmon were the sudden torches that lit up the sky in ways no one saw coming. The first, C2025, R2 SWAN, was discovered on September 11, 2025, and almost immediately made headlines because of how fast it revealed itself. Within only a day, it reached perihelion, sweeping just half an astronomical unit from the Sun, and by October 21st, it would pass Earth at a distance of only 0.25 astronomical units, or about 37 million kilometers. That is close in cosmic terms, and it gave observers a perfect chance to follow its behavior in real time. What made SWAN unforgettable was the size of its tail, stretching across the sky to 10 times the width of the full moon. Its brightness rose to magnitude 4, strong enough to be seen with the naked eye under dark skies, and it became a moving beacon in the pre-dawn hours for people in the northern hemisphere. Astronomers believe that its orbit is non-periodic, which means it may not return within the history of human civilization. It is likely that the year 2025 was the one and only chance for us to see this icy traveler alive. While SWAN was blazing across the morning sky, another surprise was preparing in the background. C2025, A6 Lemmon, started out as a faint object at magnitude 21, so dim that only the largest telescopes could catch it. But as October went on, it suddenly erupted in brightness, climbing to magnitude 3 or 4, which made it more than 200 times brighter than early predictions. By the time it reached perihelion on November 8th, Lemmon had become one of the easiest comets to spot in years, glowing in the evening sky after sunset. Its orbit suggests a cycle of more than 1,000 years, so if it returns at all, it will be long after this generation has passed. The fact that Lemmon went from an invisible blur to a naked-eye object in a matter of weeks reminded scientists of one truth: comets are unpredictable rebels, capable of rewriting forecasts overnight. Together, SWAN and Lemmon proved that even with the best models, the sky still holds surprises that can outshine expectation. Their sudden brightness created not just a show for casual observers, but also a laboratory for scientists studying how fragile ice bodies react when solar heat cracks their crusts. The question that followed was obvious. If these two torches could transform so quickly, what might the lesser-known comets of 2025 still be hiding? While the spotlight often falls on the brightest stars of the show, the 2025 comet season also featured a group of quieter players that made the cosmic stage feel more crowded than ever. These objects did not blaze across the sky like SWAN or Lemmon, but together they added depth to the rare swarm. Each one carried its own quirks, and their combined presence helped turn the season into something truly historic. One of the most intriguing was C2025 K1, another discovery from the Atlas survey. It reached perihelion on October 8th at a distance of only 0.33 astronomical units, closer than Mercury ever gets to the Sun. Such an approach put enormous stress on its fragile nucleus, and astronomers warned that it might not survive intact. For researchers, K1 was a chance to watch how small icy bodies behave when pushed to the very edge of solar heat. Another participant was C2022 N2 Pan-STARRS, which had already been on the books before the swarm began. It reached perihelion on July 31st, marking the quiet opening of the season. With its rounded coma and short fan-like tail, it was never bright enough for casual observers, yet it provided scientists with steady data on long-term dust emission. C2025 E1 Pan-STARRS, by contrast, was even harder to see. Located in the Hydra constellation and shining only at magnitude 19.8, it demanded the largest professional telescopes to track its faint progress. Though invisible to most, it reminded astronomers that every swarm hides tiny pieces that matter to the bigger puzzle. 414p stereo added another layer of interest. With a regular cycle of 4.67 years, it reached perihelion on September 27th at about half an astronomical unit from the Sun. Its brightness peaked near magnitude 10 or 11, which meant it was a target for amateurs with medium telescopes. Because its orbit dipped below the ecliptic plane, spacecraft like stereo could provide unique angles, giving scientists an unusual perspective on solar interaction. Closing the sequence was 240p NEAT, a periodic comet with a 7.6-year orbit. It reached perihelion on December 19th at 2.12 astronomical units, much farther out than the others, and its faint glow of magnitude 13 or 14 limited it to dedicated observers. Even so, its presence underscored how packed the inner solar system had become by the end of the year. These lesser-known comets may not have stolen headlines, but they helped complete the picture of a once-in-a-lifetime event. Together, they turned the swarm into a true ensemble, reminding us that even background players can shape the drama of the cosmos. But if the quiet ones carried value in numbers, what secrets would the combined data from every major telescope reveal once scientists looked closer? The comet swarm of 2025 was not only a visual event, it became one of the most ambitious scientific campaigns of the decade. Every major observatory on Earth and in space turned its attention toward the visitors, collecting light, spectra, and images in a race against time. From Hawaii to Chile, from space telescopes to small university labs, the network of eyes created a global watch unlike anything seen before. One of the most striking results came from Gemini North, which captured what astronomers described as a cosmic rainbow. In the images, 3I Atlas appeared like a string of glowing jewels, each color revealing a different gas or dust particle escaping into space. This rainbow pattern gave scientists a direct way to measure chemical fingerprints, proving that interstellar material could look very different from the comets born under our Sun. The Hubble Space Telescope added another layer of detail. It recorded strange droplets of dust clustered around the icy core, like beads floating in a halo, a shape rarely observed in local comets. These structures hinted that the nucleus of 3I Atlas might be breaking apart unevenly, opening questions about its internal strength and history. Meanwhile, the James Webb Space Telescope prepared for its chance as the comet moved toward perihelion at the end of October. With its infrared vision, Webb could detect faint molecules hidden inside the coma, catching signs of carbon dioxide, cyanide, and even heavy metals like nickel. For scientists, this was the treasure, a complete chemical library from an object older than the solar system itself. The cooperation went beyond single telescopes. Data from Palomar in California, Subaru in Hawaii, and several instruments in Chile were shared across teams, building a layered picture of the swarm. Never before had so many observatories worked together so quickly, all driven by the knowledge that once the comets moved on, the chance would vanish forever. The campaign showed what humanity could do when faced with a fleeting mystery, turning scattered instruments into a single global laboratory. Yet the rainbow of data also carried a challenge. If these early results already hinted at new chemistry and fragile structures, what would happen when the comets pushed deeper into the sun's magnetic field? When comets dive close to the sun, they enter one of the most dangerous environments in the solar system. The heat is intense, the radiation is constant, and the magnetic fields twist like invisible storms. It is in this region that comets often experience what scientists call a disconnection event. The glowing ion tail that streams behind them can suddenly snap off, breaking away in minutes before a new one grows back in a different direction. This happens when the comet crosses sharp changes in the solar wind or gets hit by a coronal mass ejection, a burst of plasma and magnetic force shot out by the sun. One famous example came in 2007 when the Stereo spacecraft watched a comet's tail cut cleanly in half by such a blast, a perfect case that matched computer models almost frame by frame. Now, with 7 comets rushing toward the inner system in late 2025, the odds of catching these events are higher than ever. Astronomers are not only excited, they are also uneasy, because this is a natural experiment on a scale no one has witnessed before. Some scientists at NASA's CCMC believe that the extra plasma and dust released by so many comets at once could even nudge the sun into producing stronger outbursts. Their simulations show that when a dense comet tail interacts with the heliospheric current sheet, the magnetic geometry can shift quickly and trigger chain reactions. If true, this would mean comets are not just victims of solar storms, but also players that can feed new instabilities into the system. But not everyone agrees. Teams working with Solar Orbiter and the Parker Solar Probe argue that comets do not have the mass to change the sun's behavior. They point to years of data showing that most tail disruptions are small, more like ripples than explosions, and that the sun's own cycles remain the main driver of violent events. In their view, comets are markers, not triggers, valuable for tracing changes in the solar wind, but not responsible for creating them. Whichever side is right, the 2025 swarm is giving researchers a rare test, a live theater where models and theories will be judged against reality. Every twist in a tail and every sudden break is now being recorded by telescopes on Earth and spacecraft watching from orbit. And beyond the science, the sight of multiple comets struggling against the fury of the sun has already stirred memories of how past civilizations once read the sky. If ancient people saw comets as omens of war and change, how will today's society interpret this fiery drama? For as long as humans have looked up, comets have carried more than light, they have carried meaning. Ancient civilizations often saw them not as natural objects, but as signs of change, messages written across the night sky. In Babylonian records, comets were linked to the fall of kings, while in China, they were logged as warnings of war or famine. Every sudden streak of light was a story waiting to be told, and most of those stories carried fear. One of the most famous examples came in 1066, when Halley's Comet appeared in the months before the Battle of Hastings. The site was stitched into the Bayeux Tapestry, a piece of medieval art that showed the comet as a fiery omen above the armies. To those living through it, the glow in the sky seemed like a judgment, a cosmic vote on who would rule. In the 14th century, as the Black Death spread across Europe, comets were again painted as symbols of death. Writers described them as swords of fire, cutting across the heavens, a reflection of the plague that was cutting through villages. The science of today may explain comets as ice and dust, but the cultural memory of fear and awe still shapes how people react. Even in the modern era, Halley's return in 1910 sparked panic. Reports claimed its cyanide-rich tail might poison Earth's atmosphere, leading to sales of comet pills and gas masks to anxious buyers. The fear passed, but the moment showed how fragile human confidence can be when the sky behaves strangely. Now, in 2025, 7 comets arriving almost together is stirring the same old questions. Are they just icy wanderers crossing our field of view, or do they still carry the weight of ancient omens? Some cultural researchers suggest that the symbolism has shifted. Instead of fear, many now see comets as symbols of discovery, reminders that the universe is still full of unknowns. Yet the echoes of history remain. When the sky fills with fire, the human instinct to search for meaning is never far behind. And while scientists track plasma tails and chemical spectra, ordinary people may still ask what story the heavens are trying to tell. If these streaks of light are no longer warnings of kings and plagues, could they instead become a call for unity, a sign to watch the sky together? The comet swarm of 2025 is not just for scientists, it is also a rare chance for the public to look up and see history with their own eyes. Unlike many past events that stayed hidden behind large telescopes, several of these comets will be bright enough for anyone with patience and clear skies. The first highlight is SWAN, which will shine brightest in mid-September. Observers in the northern hemisphere should look for it after sunset, where its long tail will stretch across the twilight sky. Even without equipment, it could appear as a faint glow, but binoculars will reveal the structure more clearly, showing the tail like a ghostly fan of light. Later in the season, Comet Lemmon will take center stage. By late October, it will rise high enough, about 42 degrees away from the sun, to be easily spotted with simple field glasses. Forecasts suggest it may reach magnitude 3 or 4, which means it could even be visible to the naked eye in dark areas far from city lights. For many, Lemmon will be the easiest comet to catch, glowing in the southwest evening sky after sunset. 3I Atlas, the interstellar giant, will not be so simple. Its brightness is expected to stay below the naked eye level, but dedicated amateur astronomers with medium-sized telescopes may track it in early 2026. For them, every glimpse of this rare visitor will be a record of something that will never return. Other members of the swarm, such as C2025, K1 Atlas, 414P Stereo, and 240P Neat, will remain faint targets. These will challenge more experienced skywatchers who enjoy the patience of hunting dim objects against the starry background. The beauty of 2025 is that there is something for everyone, from casual stargazers to professional astronomers. Even a short moment under the night sky can connect people to the larger story unfolding overhead, making them part of a global observation campaign. And while many will be busy enjoying the view, others are preparing new tools to make the most of this rare natural laboratory. So how is technology being pushed to its limits during the swarm, and what does it mean for future comet missions? The comet swarm of 2025 is not only a spectacle in the sky, it is also a test ground for technology. For the first time, nearly every major telescope on Earth and in orbit has been called into action at the same moment, turning a natural event into a global experiment. The Hubble Space Telescope continues to deliver high-resolution images, catching faint dust halos and unusual structures around the comet cores. The James Webb Space Telescope adds another layer by reading the chemical signatures in infrared, detecting gases and ices that older instruments could not see. Together they create a combined map, a picture that shows not just what the comets look like, but what they are made of. Ground-based observatories are equally important. Gemini, Palomar, and Subaru are working almost daily, tracking brightness changes and tail movements. By comparing data across continents, scientists can follow eruptions in real time, building a timeline that no single observatory could achieve alone. This cooperation has shown how much astronomy has changed in the past 20 years, from small isolated projects to a worldwide network. But the real excitement lies in the missions being built for the future. The European Space Agency has already developed Comet Interceptor, a spacecraft designed to wait in space until a new comet or interstellar object is found. Instead of launching after discovery, it will already be in position, ready to race toward the target and collect data up close. Some researchers suggest that after 2025, humanity should prepare to go even further. If another interstellar visitor like 3I Atlas appears, there may be a push to send a probe fast enough to meet it before it leaves the solar system. That kind of mission would demand new engines, stronger shields, and faster planning than ever before. The swarm has reminded scientists that the universe does not wait for us, and opportunities can vanish in months. For young engineers and astronomers, this is a call to action, a chance to design tools that can catch the next messenger from beyond the stars. The 2025 swarm may end, but the race it has started is only beginning. And if the sky gave us this many surprises at once, what might the next chapter hold when the unknown comes knocking again? The Comet Swarm of 2025 is not only a rare show in the night sky, but also a reminder of our fragile and fascinating place in the universe. For scientists, it is a natural laboratory that will shape discoveries in the future. For the public, it is a once-in-a-lifetime chance to witness this natural wonder. The universe is vast, and every moment that flashes across the sky is priceless. So be ready when it appears, and capture those special pictures to remember it.